Welcome to solverfy.
Two satellites orbit, one at 5,000 kilometers, one at 15,000 kilometers. We're going to say that, we know based on the formula for the gravitational force that the closer satellite will have a greater velocity than the farther satellite. So we can simply say that v close will be greater than v far. We already know that based on the formula for the gravitational force. So we can say that the only force on a satellite would be the gravitational force. This would be equal to the mass times the centripetal acceleration. This would be equal to mv squared over r. And we know that the force of gravity is equal to the gravitational constant times the mass of the satellite times the mass of the Earth divided by the radius, or in this case, the distance from the satellite to the center of the Earth. So we can say that v, the velocity, will be equal to the gravitational constant times the mass of the Earth, given that the mass of the satellites cancel out. This will be divided by r, the distance from the satellite to the center of the Earth, all to the 1/2 power. So we can say that the velocity is going to be inversely proportional to the square root of the distance between the satellite and the center of the Earth. So if this is the case, we can create a relationship and say v close divided by v far would be equal to the square root of the radius far divided by the radius close. And we can solve. So we can say v close. So this would be one answer. We know that for a fact. And then this will be divided by v far. And this is equaling, we'll say, the radius of the Earth plus 5,000 kilometers, or rather 15,000 kilometers. So 6.38 times 10 to the 6th meters. And then we can say plus 1.5 times 10 to the 7th meters. And then this will be divided by, again, 6.38 times 10 to the 6th meters plus 5 times 10 to the 6th meters. 5,000 kilometers. And this is giving us 1.37. So we can say that v close is going to be equal to 1.37 v far. So this would be our answer to the second part. That is the end of the solution. Thank you for watching.